this video, we're going to discuss some very simple probability rules and then talk about how to interpret probability. Okay, so before I bring up the probability rules, first I just want to do some notation for probability. You'll see P, which will denote probability. It's like a capital P. A lot of times I will use PR to not get confused with other P's that we'll use later in the semester. So PR is my preferred notation. So this will denote probability. Okay. A, B, C, E. These are common letters that are used for specific events. Okay, so these stand for some sort of event. So it could be, the event A is rain tomorrow. Okay, so then PR of A would be the probability of it raining tomorrow, the probability of event A occurring. Okay, so this stands for probability of event A occurring. All right, so we'll be using this sort of notation, probability of some sort of letter, a lot as we continue. All right, so now let's go ahead and talk about some rules of probability. So 3 simple rules. The first is that probability should always be expressed as a fraction or a decimal. All right, so the probability of an event, so say the probability of rain could be 0.5, right? Which you would interpret that as a 50% chance of rain. So usually you interpret probability as a percentage, but the actual probability should always be a number that is between, so the probability of any event A should always be a number that's between 0 and 1, so a fraction or a decimal. Okay, so probability of event A. All right, so the probability of an impossible event is 0, right? So if the event is impossible, so the probability of rain, I would imagine, is rarely actually 0, because it has to be really impossible. Like the probability that, what's something that's impossible? It's hard to think of, possible events actually. I guess the probability of rolling a dice, that 6-sided die that only has 1, 2, 3, 4, 5, and 6 on its sides, and so the probability of getting a 7. Well, that's impossible. You can't get a 7 on a 6-sided die. There's no 7 there, right? So the probability of that event would be 0. All right, so the probability of an event that is certain to occur is equal to 1. Okay, so if the event is, what's the probability of getting a heads or a tails when you flip a coin? So say the event is getting a head or a tails. Well, that would be not 0. I should have meant to write 1 there. That'd be guaranteed to happen. You're definitely going to get a heads or a tails. So that would be equal to 1. Okay. Let's do a few more examples of interpreting probabilities. So this is kind of a reminder because we just talked about this. So if the probability of some event is 0, then E cannot, it's impossible to occur, right? Okay, so if the probability equals 1, then E will occur. There's no, it's guaranteed to occur if the probability equals 1. Okay, the probability of an event is 38% or 0.38. Then the way we would interpret this is, like I said, we often interpret probabilities using percentages, but the probability itself is actually a decimal. So if the probability of the event is 0.38, then E will occur, the event E will occur 38% of the time. All right. So say if the probability, if E is like flipping a coin and getting a head, right? If E is getting a head, then this would be a weighted coin in that case. If the probability of getting a head is 38%, so that would mean that getting a head will occur 38% of the time that you flip the coin, right? So what if the probability is 0.0001? Right, well, we could say, okay, well, E will occur 0.01% of the time. Right? A better way to interpret this would be say, okay, E rarely occurs, right? 0.01% of the time is pretty rare. So E rarely occurs. Okay, so whatever the event E is, it doesn't show up very often in your in the realm of possible outcomes. Whatever the event E is, it's not a very common outcome.